Hello friend, what's up? I hope you all are doing fine. First of all, thank you for coming on my YouTube channel, Know Your Universe, and I will make sure that you know your universe. This is my first video and it's about wormholes, space and time. I picked up one of the most delicious and intriguing topics of astronomy and physics. So fasten up your seatbelts because we are going deep in the darkness of wormholes and black holes. We would be talking about the major three questions that are wormholes there, and if they are there, what's their working, and if they are there, where are they? Okay, let's get into it. According to general relativity by Albert Einstein, they are real, but general relativity overall, it's kind of a difficult theory to understand. General relativity is a set of mathematical equations which gives many solutions, like, for example, this is just an example, like a quadratic equation which gives you a positive or a negative solution. Black holes and wormholes came from a similar kind of equation only. It was a quadratic equation. So one part gave black hole and the other part gave, let's say, white hole. That's actually what it gave. But here's the deal. These equations can be satisfied theoretically on paper, but not all are real. Okay? Like for a while ago, we never believed that a thing called black hole would exist, but in 2019, we got the picture, we got the proof, so now we know that it is real. But with wormhole, the chances are even smaller because the situations are very difficult to exist and many solutions are not true in reality. So, according to Newton, we live on a flat space. Okay, here's an example. This is a sun, this is a earth. Force has been exerted, moving back gravitational force field, and hence the name law of universal gravitation. The most important statement that later was proved wrong, that space and time are absolute. Now, what's the meaning of this? It means that space and time are two separate things. But then came Albert Einstein. He said that space and time are not absolute, they are relative to each other. And space is not a two dimensional structure, it is a three dimensional structure. Now, if we include time, then there are four dimensions. And he also said that nothing in this universe is frozen at a place or nothing is at rest. Everything is moving. As you can see in this picture, this is Newton's fixed space which cannot be curved. Our earth is lying on a flat surface here. But in Einstein's flexible space-time, the space-time is curved, as you can see here. According to Newton, the gravity is caused because of the mass of the object here. But according to Einstein, it was because of the energy that a body had. Newton's space is flat. Here you can see Einstein's space-time is curved. Space-time, remember that, because Newton said that it's only space, it's absolute, but he said that it's relative. Space and time both exist at the same time. They can differ, but they exist together. You might have seen this diagram. It shows Einstein's space-time, how it is curved. But in reality, you don't see anything like this. This is just 2D. This is what it really looks like. Again, we cannot see this thing. We can see this space-time is curved by an object inside. Let's say it's a sun. This three-dimensional grid gives a better idea of what curved space-time might look like than the two-dimensional analogies do, like this one. This is just for the sake of understanding. Now you know what a space-time looks like. So this is a visualization of a wormhole. In this picture, we can see that the space-time is curved to such an extent that it creates a hole inside it. This hole is passing to a different point in space-time. You might have seen this explanation in a movie like Interstellar.
So they say you want to go from here to there, but it's too far, right?
Mm-hmm.
So a wormhole bends space like this, so you can take a shortcut through a higher dimension. Okay, so to show that, they've turned three-dimensional space into two dimensions, which turns a wormhole into two dimensions. A circle. What's a circle in three dimensions? Sphere. Exactly. A spherical hole.
So a wormhole is not a disc, it's like a ball. So a wormhole first came in existence in 1935 when Einstein with a scientist a physicist partner colleague, Nathan Rose, they made a solution out of relativity, which was later on called Einstein-Rose bridges, and finally we call them nowadays wormholes. The theory said that one side of the wormhole would be a black hole which would absorb everything, then through a tunnel exert everything out into a parallel universe through a white hole. This parallel universe might be a place where the times run anti-clockwise, might be a place where mass is negative. For an example of a wormhole, you might remember the Bifrost bridge in Thor. Okay, it's an example of an Einstein-Bose bridge. It's too fictional. So now let's talk reality. When the equations were solved, it was understood that it would take infinite time to go from one end to the other end of a wormhole, which means that this kind of wormhole can't be used for traveling. Instead, we can use transferable wormholes according to string theory. We have seen such wormholes in Netflix series like Dark or in Avengers movie 2012, where Tesseract Cube was used. We would talk about it in a later video. So this is some extra knowledge for my nerdy bros. You can Google this part, I will not explain. After Big Bang, space-time quantum fluctuation at a smaller scale at Planck's length might have created many transferable wormholes with cosmic strings after the Big Bang. You can search it. This is not too important. This is how the wormholes were shown in the series Dark. They were connected with strings and had openings at different places at different time. We will talk about time travel in a later video. Some people even say that the center of a Milky Way galaxy, which is said to be a black hole, is not actually one, it's a wormhole. But again, I think it's hypothetical. So why don't we just make our own? Can we even make one? So first problem is we cannot use a wormhole. So a wormhole, just like a black hole, can have big gravity and this can crush us, or a process called spaghettification. Okay, this is what it looks like. Next problem is again the gravity. How can we keep it open? Because everything is closing in together. Mass attract each other. So we need a negative mass, which is exotic matter. We will talk about it in later videos. The last problem is that we cannot use it from both sides, because one side need to suck something in to give out on the other side. So if we go from one side of wormhole, then we cannot re-enter through the other side. In conclusion, I would say that this theory is good in books and movies only, but science always keeps us surprising. At the end, I just want to say thank you for watching this video. If you learned anything new from this video, please drop a like. Goodbye. See you soon.